Welcome to lesson 143 of algebraic concepts, or lesson 2143 overall. We're going to simplify rational expressions. So here's our objective, our vocabulary, our rules and notes, and a picture of a rational expression. So today we're going to go a little bit further in simplifying rational expressions. So yesterday, or the previous video, was a introduction. Today is the more work. So let's get on to it. So if you recognize the top trinomial, if I put my pen on, which I forgot to do, the top trinomial is a difference of squares. So we're going to take that as x minus 3, x plus 3. And there we go. And so now, to simplify the last trinomial, 3 has two factors, 3 and 1. So I know one of them is going to be x minus 3, and then the next one is going to be x plus 1, because negative 3 and positive 1 makes negative 2. And as we can see, the x minus 3's cancel out, and we're left with x plus 3 over x plus 1. So now this is simplified. The next step is to find where this function does not exist. So set the bottom equal to 0. And at negative 1, when x equals negative 1, this function does not exist. That's called an excluded value. And I forgot to tell you that to you in the last video. The places where the denominator, where the bottom is 0, is called your excluded values. And also, the x minus 3, before we crossed it out, if you set x minus 3 equal to 0, because it multiplies to x plus 1, you also have to take that. So maybe I should look for the excluded values before I cancel out the things. And I'll do that in the upcoming videos. So I don't want you to get confused by that. So when we start with example 2, we are going to work on the excluded values first. Those are where the denominator is 0, and then we are going to simplify it further. So let's do the first things first. So let's take out 3. So x squared minus 5x plus 4. And that's 6 times x squared plus 4x minus 5. Okay. So the factors of 4, 2 and 2, 4 and 1, x minus 4, x minus 1. So we got 3 times the quantity x minus 1, x minus 4, all in the numerator. And then 6 times the quantity, let's see, 5 and 1. X plus 5, and then x minus 1. Okay, and so let's simplify the outside. 3, 6 turns into 1/2. And remember, when we multiply, we can switch around factors, and it does not change the outcome of the answer. So I did this just to show you what cancels out. But before we do that, we're going to find the excluded values. So we're going to set x minus 1 equal to 0, and x equals 1. We're going to set x plus 5 equal to 0, and that equals x equals negative 5. And so now these are the two places where the function does not exist. So now that we found that, let us then cancel out the x minus 1, a like term, and we get x minus 4 over 2 times x plus 5. Our example 3. All right, on the surface, these do not look very similar. But if we look at the bottom and we factor out a negative 1, x minus y over negative 1 times x minus y, we see that they cancel out. And 1 over -1 equals -1. Okay, so that's the answer. So when x minus y, which is our denominator, equals 0, x equals y. Because these are both variables, so I guess this does not exist on the line x equals y. And if you remember anything about graphing, you should be familiar with what the graph of the line y equals x or x equals y looks like. And when we graph, we always put the y on the left. So those were our 3 examples. Please work on upcoming practice problems on a separate piece of paper, and I will see you at the end of the video for a short recap. Okay, so what do we have here? We have a P and a Q in both of them. So if I take out a non-P Q, so what did I take out? I have P plus Q up top. And what do I take out of the bottom? I take out 3P, which leaves me with P squared minus Q squared. And look at this. This is the classic definition of a difference of squares. So P squared minus Q squared equals P plus Q times P minus Q. So now, rewriting this down here, you got non-P Q over P plus Q over 3P P plus Q P minus Q. Let's look for our excluded values. So 3P equals to 0. When P equals 0, this function does not exist. P plus Q. So when P equals negative Q, and then P minus Q equals 0, P equals Q. All right, so that's a couple of lines, and that's a Q, and this is a Q. Wow, that's a couple of lines. So this will be an interesting one to graph. We found our excluded values, and ironically enough, our excluded values includes 2 lines and then a constant term. So now that we found our excluded values, let's cancel out what's alike. 9 divided by 3 is 3, so you got 3Q in the numerator over P minus Q. And that is your simplified answer. Okay, so 4 minus n squared plus 6n plus 8. So what are the factors? 4 and 2 minus 4 minus 2 will give you 6. Okay, so we get 4 minus n over n minus 4 n minus 2. Okay, so now we're going to have to do a little trick here. We're going to have to multiply the top or factor out of the top a -1. So on the top we get n minus 4 over n minus 4 n minus 2. Now the second thing we're going to do is look for our excluded values by setting both factors equal to 0. Okay, here are our excluded factors, 4 and 2. And now we cancel out what is like, and we're left with 1 over n minus 2. Oh, I'm sorry, I factored out a -1. That's -1 over n minus 2. So don't forget about your signs. They are very important. And I almost did before I left this problem. Okay, so let's look at another problem here. We got 9 minus t squared. But if I factor out a -1, I get t squared minus 9 over t squared plus, that's a perfect square trinomial, so you get t plus 3, -1 over t plus 3, t minus 3, all over t plus 3, t minus 3. So now, once we do that, let's go to our excluded values. T plus 3 equal to 0, and t minus 3 equal to 0. And then, so t equals -3, and then t equals 3. These are excluded values. -3 and 3 is where the function does not exist. And now we can cancel out what is alike. Oh, wait, no, t plus 3. I'm sorry. That was t plus 3 twice. I'm moving a little too fast, and this is what happens to you. So t plus 3 equals 0. It was the same factor. This one did not count. Don't worry about that one. And so we cross one of them out. And we're left with -t minus 3 over t plus 3. And that is the answer for that one. And I could distribute that -1 and do 3 minus t over t plus 3. I could do that. And now it's simplified because you don't have a negative outside of something. You know what? I don't know if math teachers will complain if you left it like this. Some may, some won't. But just for technically, this is the correct way to look at it. If you're taking a standardized test, you will definitely see the second one. So be on your P's and Q's when doing things. Okay, so the final problem. All right, see, 15 and 10 have a common factor of 5. So let's take out 5a. That leaves us with 3a plus 2. Okay, so this gives us a hint about the second one. So let's take 3a squared plus 5a plus 2. Let's try 3a plus 2 as one factor, and then a plus 1 as another factor. So you get 3a squared on the inners, 2a, 3a, 5a, 2. Yeah, that works. So sometimes when you factor the top, it will give you a hint about what to do with the bottom. So now we got 3a plus 2 times a plus 1. So as you know, we're going to go and find our excluded values. Subtract 2. You got 3a equals negative 2. Divide by 3. A equals negative 2/3. Okay, so let's look at a plus 1 equals 0. Subtract 1. Subtract 1. A equals negative 1. Okay, so those are our two excluded values. And now we can go ahead and cross out what's alike. So our simplified solution is 5a over a plus 1. So thank you for watching the video. If I moved a little bit too fast or you're a little unsure, please go back and watch the first video where the problems were a little bit simpler. Thank you for watching the video. I hope to see you again. This is a series of videos dealing with rational functions. I hope to see you on the next video.